Now that you have a good, even though it's just the beginning, understanding of some of the basic concepts in Arduino programming, we can move on and have a look at how to use the digital input and output pins that come with the Arduino. Of course, input and output are fundamental features of the microcontroller. You can connect devices to special pins on your Arduino and read or change the state of these pins through special instructions in your sketch. There are two kinds of input and output pins on the Arduino. There are digital and analog pins. We'll start with digital pins. Digital pins are useful for reading the state of devices like buttons, like this one, and switches, or for controlling things like relays, transistors, or LEDs, like this one. All these examples have one thing in common. They have only two possible states. Think of the button, for example. A button can either be pressed or not pressed. Or think of an LED. An LED can be lit or not lit. If in your sketch you'd like to know the state of a button, then you can connect it to a digital pin. You configure the digital pin as an input, and then when you press the button, you read the state of that pin, and if it is 5 volts, then you can deduce that the button is pressed. Similarly with an LED. If you want to control the state of the LED to be able to turn it on and off, then you can connect the LED to one of the digital pins, configure the pin as an output. Okay, it's an output because we're trying to alter the state of a connected device, and then programmatically write a 5-volt value to that output, and that will have, as a result, the LED lighting up. To begin with, I'd like to show you how to connect an LED to your Arduino and then control its state programmatically. So programmatically being able to turn it on and off. I'm not going to show you a schematic in this lecture, so I invite you to follow along with the assembly of your circuit just as I am assembling it as well on the video. To follow along, you will need, of course, a breadboard and your Arduino. You'll need an LED, a 5mm LED will do just fine, and you will need a resistor. The purpose of the resistor is to protect the LED from burning out. Because the LED internally only has very little resistance, it is possible to get a lot of current flowing through it if that current is not going first through what's called a current limiting resistor. The resistor that I have here is 220 ohms, but if you don't have the exact value, you can go for something larger. Even up to 1 kilo ohm will be able to work with this circuit. It's just that the larger the resistor is, the fainter the light coming out of the LED will be. But don't go for anything smaller, because the smaller the resistor is, the more current will flow through the LED, and the more likely that eventually your LED will expire and will be damaged. Another thing that will be helpful to have is a coin cell battery. And this is why. If you've never played around with an LED before, you notice that LEDs come, usually, there's an exception to this, but in most cases LEDs come with 2 pins, and one is longer than the other. This indicates the polarity of the LED. So LEDs have to be connected in a particular way to work, and either if they are connected in reverse, they won't work. The long pin of the LED is called the anode, and that is the positive side of the LED. And the short pin, the short side of the LED, is the cathode, and that is the negative pin of the LED, the negative side. So obviously you connect your positive to one of the Arduino's pins, and the negative will go to the ground. If you can't remember which one is which, then you can use the coin cell battery as a tester. You can also use the coin cell battery to test if an LED is burnt out or if it still works. So take a coin cell battery and just connect your LED to it like that. So one pin will go to either side of the battery. And you can see that the way that I've connected it now, the LED is turned on. And it's because I connected the long pin of the LED to the side of the battery with a plus sign. You can see that here, plus sign means positive side of the battery. If I connect the LED in the other way around, so short pin to the positive side of the battery, you'll see that it doesn't work. And this is how you can tell which pin of an LED is positive or anode and which one is negative or cathode. So here's my anode. I'm going to connect my anode pointing towards the left on my breadboard. So left is anode for me. Just an easy way to remember, like that. Then we go to the resistor. So take your resistor and plug it either on the cathode of the LED or the anode. There you go. Either one way or the other is fine, because the current that will eventually flow through both devices doesn't really care whether it goes through the LED first and then the resistor or vice versa. The amount of current that flows through both devices together will limit itself depending on the total resistance in the circuit which contains the LED and the resistor together. So whether the resistor is before the LED or after doesn't matter. I typically connect it on the anode just because it's easier for me to remember then where the anode is. So once you have your resistor and your LED connected in your breadboard like this, take a jumper wire and connect the unconnected side of the resistor to any one of the digital pins. So any one of the pins of the long header can be used as a digital output, except for the one marked AREF here, which I'm going to talk about another time, not today, but that is not a digital pin. So I will connect it to digital pin 8, like that. Now take another jumper wire, connect it to the cathode of the LED, like that. And then this wire has to go to any one of the 3 available ground pins on the Arduino Uno. So we've got a ground pin right here. We also have ground pins here on the short header, the power header. Since we are working with digital pins on the long header of the Arduino Uno, rather plug it into this ground pin so it's closer right here. So I don't have to stretch the wires too much. Alright, so our circuit now is ready. We're going to leave the USB cable unconnected for now and move on to the Arduino IDE to put together the sketch that will control the red LED. You could actually go and get one of the examples called Blink, so through the File menu, Examples, Basics, and then Blink, and that will bring up the sketch that I'll be typing in and putting it together. But I prefer to just type it here because it's a small sketch, but also will give me the opportunity to describe what I'm doing as I'm typing it. The first thing that you do when you want to use a digital pin is to configure its mode. Remember that digital pins can be either inputs or outputs. So you need to tell the Arduino whether you'll be using an input or an output pin with your component. In this case, since we are using an LED and that's what we want to control, we want to configure the pin as an output. So for that, we use the instruction pin mode. It takes 2 parameters, and the first parameter is the number of the pin that we want to control. In our case, we've got the LED connected to pin number 8. It means that its anode is connected to pin number 8. So here I'm going to type 8. And next, I need to tell in the same instructions, the second parameter, that this pin is going to act as an output. If I wanted this to be controlling or to be reading the state of a button, as we'll see later, then I could have said input here. So the two valid options is either input or output. And always we end with a semicolon with our instructions. That's all we need to do in order to get pin number 8 to act as an output. Let's go to the loop. Let's say that the effect that we'd like to create here with our LED is to turn it on for a small amount of time and then to turn it off for a small amount of time. What we want to do then is to control the state of pin number 8. And the instruction we use to do that is digital write. So digital write again takes two arguments, two parameters. The first one is the number of the pin that we want to control, and the second one is the state to which we want to take that pin. So in our case, we want to take pin number 8 and turn it on. And the keyword for that is high. So you can have a pin either as at high state or low state, one or the other. There's nothing in between since it's a binary system. So I'm taking pin number 8 and I'm taking it to high state, which means that I'm going to now write a 5-volt value to it. And I would like to keep that value there for a small amount of time. Let's say 1000 milliseconds. So the delay function allows us to insert a delay in our sketch. Whatever the previous instruction was, we are going to insert a pause here, and that instruction will remain as it is. And we are only going to change it in the next instruction, line number 10, where again we want to go to pin number 8 and now switch it off. From 5 volts, take it down to a low, which is 0 volts, so the same level as ground. And again, we'd like to keep that instruction for 1 more second. So our LED in line number 8 will be turned on because we are writing a high to digital pin 8. We're going to keep it high for 1 second. And then in line 10, we're going to write a low and keep that for another second. Then the loop finishes, so it means that it's going to go back to the beginning and execute the same instruction again. So that's it with the construction of the sketch. Let's plug the USB to our Arduino and upload the sketch. So I've got the right Arduino, it's Arduino Uno, and I've got the correct board connected. So I'm going to click on the upload button. Of course, I need to save it first. So yep, that's fine. The default directory. I need to change the name. It's fine. So uploading, and there's the LED blinking on and off for 1 second each. You can change the duration, for example. Let's leave it on for 1 second and off for half a second, and upload again. There you go. So you change the durations very easily. So I invite you to experiment a little bit with this. How about you create a sequence of LED blinks to replicate the SOS Morse code using your LED. So all you've got to do for that is to turn the LED on and off for the appropriate amount of time and number of times so that the SOS Morse code is replicated with your LED. Just a little exercise before we move on. So when you're ready to continue with the next lecture where I'll show you how to use the button.